So now we're going to move on to rational expressions that may have binomial or trinomial denominators. Now, when I look at this problem, when you see it first, you're probably going to think that the LCD is x minus 5. But the problem with that is the only way that I can make this x minus 5 is by subtracting 5 from it. And we don't have any rule that says we can subtract from the numerator and denominator, it's only multiply. To do that would be like saying 5/6, actually we'll make this 6/7 so it kind of matches with what we're doing. 6/7 and I minus 5 from the numerator and denominator equals 1/2. And we know that 6/7 doesn't equal 1/2, so we can't use that method here. So when we have these binomials, if they're different binomials and monomials, we need both of them in our LCD. So my LCD is actually x times x minus 5, and we want to write it in this factored form, and we're also going to write it simplified, so that's x squared minus 5x. The factored form is nice because that lets me see what each fraction is missing. So my first fraction, if I look at my denominator, is missing the x minus 5. And my second fraction is missing the x. So when we multiply this out, we get 2x minus 10 over, and when I multiply it, I'm going to write it multiplied out, x squared minus 5x. And here I have 3x over x squared minus 5x. So now we're going to combine like terms. As I said, the steps are always the same. Right? So we add the numerators. 2x plus 3x is 5x minus 10 over x squared minus 5x. Now I always want to check for that simplifying, so I'm going to factor this. My numerator factors to 5 times x minus 2, and my denominator, which I already have factored up here, is x times x minus 5. When I notice that that doesn't help me to cancel anything, I'm just going to cross it out and keep this answer. Now, if you can do that in your head and know that there's nothing you can cancel, that's fine. That is my final answer. So on the next page, we have a couple different ones. You might want to try these first. Basically, we're going to go through these 4 in this video. So this next one brings in something else where part is a fraction and part's not. We can just put that over 1, okay, and basically work from there. So my LCD is pretty simply just this x minus 3. So my first fraction is missing the x minus 3. And my second fraction is good. So when I multiply this out, I do have to use double distribution. So, right, we get x squared plus 2x, and then minus 3x minus 6, all over the x minus 3, minus 2x plus 5 over the x minus 3. We notice here we're subtracting a binomial, so I'm going to change those signs. Now I could simplify my first fraction more. I'm just going to combine all my like terms at the same time since I already have my LCD. So the whole thing is going to be over x minus 3, and here I have an x squared. 2x minus 3x minus 2x is going to be a negative 3x. And then negative 6 minus 5 is negative 11. A quick check, which I'm not going to spend too much time on, that does not factor, and that's the final answer. So moving over to letter B, that's very similar to our first example on the other page, right? We have a binomial and a monomial. So our LCD is the x and the x minus 1, which is x squared minus x, or x squared minus 1x. My first fraction is just missing the x, and my second fraction is missing the factor of x minus 1. So this gives me x squared over x squared minus x. This one gives me x minus 1 over x squared minus x. Tried to put a lot on here with this distributing the negative because it's a super common mistake to miss that. So this is going to be positive, negative, and positive. So when I go across, x squared minus x plus 1 over x squared minus x. This numerator doesn't cancel. As I said, it looks super tempting to cancel, but there's no common factors, right? These are binomials and trinomials. I'm just putting the parentheses there to show it's all included together. So that is my final answer. So the next one has one denominator that's one binomial, one that's another binomial. And if they're different binomials, we need both of them. So my LCD is the x plus 2 and the x minus 3. And if I multiply that out, I'm going to combine those like terms. If you can skip that middle step, that's great, but I just want to make sure we're clear. So I'm going to cross this out. My LCD in factored form is up top, and then my LCD simplified is below. My first fraction is missing the x minus 3. And my second fraction is missing the x plus 2. So we end up with 5x minus 15 over x squared minus x minus 6. And that's not because I'm fast, right? I know what that is from over here. Plus 3x plus 6 over x squared minus x minus 6. So now we'll combine like terms. And I get 8x minus 9 over x squared minus x minus 6. Nothing factors in that numerator, so I know the denominator factors, but that won't help me cancel anything. Moving on to our last one, we're actually all set up. We don't need an LCD, it's already there. So we just need to remember to distribute our negative. So we have 3x minus x is 2x. 7 minus 3 is 4. Now this one, I see some potential for factoring. So I have 2 times x plus 2 over x plus 2, x minus 2. Okay, so here I do have a common factor. So you should see this problem right here, kind of like that first lesson. Just consider it like that, see if it simplifies. And my final answer is 2 over x minus 2.